Hey you guys, I'm Brandon Hawbaker from Liberty Founders, and today I'm going to show you some things that aren't readily available on the internet, things that are a little bit harder to put together, to notice, to think, that's important. We're going to talk about water, and which is a basic substance of life, and it's something that you think is just pure. You assume it's pure. You assume that everything you consume with it is good, but in reality, it's not always pure. It's not always clean, and a lot of the products you think contain water are actually bad. So before we get started, I'm going to discuss plastics, because a lot of times we talk about the literal components of the actual, chemicals or substances or whatever you want to call it that you actually consume. But what I want to talk to you today to begin with is first the actual packages and what chemicals are contained in the packaging materials. So first of all, we'd like to talk about the different plastics. So as you're aware, most plastics are labeled on the containers themselves, like number 1, number 2, number 3, number 4, number 5, number 6, number 7 plastics. Number 7 is kind of a group all, but we're going to start from the very beginning, and we're going to go through all these different plastics and what are the ramifications of each particular plastic. So starting with number 1 plastic, this is number 1 plastic. It's polyethylene terephthalate, and it's the shiny kind of plastic is how I remember it. If you go to a grocery store and you're looking at like Coca-Cola bottles, number 2 2-liter bottles, you look at almost all the plastic you will mostly find is number 1 plastic. It's a very, very common plastic. You find it just about everywhere. It's very malleable. It's pretty flexible. It's easy to recycle, and that's one reason a lot of companies use it. The thing about number 1 plastic, polyethylene terephthalate, is that it contains some chemicals that are bad for you. For example, it contains antimony, which is a poisonous metal that is very toxic to the body, and it also contains a chemical called acetaldehyde as well, which is also really bad for you. These chemicals, I recommend looking up online, but basically they're very destructive to the body, they're poisonous, and they're bad for you, and you're drinking it. So avoid number 1 plastic. The second plastic is actually my favorite plastic. I've done a lot of research, and there's some controversy suggesting there's some possibility it can leach chemicals, but it's actually, but from my research, I can't find anything. And that's high density polyethylene. It's like this. It's kind of the dull color plastic, which basically, if you look at it, you can't really see through it very well, but it's pretty thick, it's pretty sturdy, it holds up pretty well. You can see from this container, it's the same kind of texture. This is high density polyethylene. Even the plastic grocery bags right here, this is high density polyethylene as well. So what's the good thing about high density polyethylene? Well, I can't find anything that suggests it actually has or leaches chemicals. In general, any plastic that you have, if it's microwaved, it's put under a lot of stress, if it has high temperatures, it can start to leach and break down. So most plastics over a course of time can break down over time. But high density polyethylene is a fairly sturdy, strong plastic, and it is somewhat common. It's not as common as PETE or polyethylene terephthalate, but it is also it's a much better plastic, much safer plastic. And if you have to use plastic, I recommend HDPE as much as possible. Okay, so the third plastic we're going to discuss is a little bit weird. It's not as common. It's PVC. I mean, not as common in food products anyways. Polyvinyl chloride. This is polyvinyl chloride. Surprisingly or not, a lot of PVC pipes underneath your house are polyvinyl chloride. But PVC basically is a really commonly used plastic, I mean, as you notice, they say BPA free to kind of reassure you, hey, this doesn't have BPA. And yeah, it actually doesn't have bisphenol A, but it does have some other qualities that are a little more controversial. For example, when it's processed, it's made with lead and a lot of phthalates that can they can actually give off gases in the air. So like in your cars, where you're actually, your dashboard and all those PVC, that can actually give off gases when it's first produced. So these toxic gases can be provided. There's some other things to be aware of with it. For example, let me see if I can find a couple examples here. There's a lot of sources. Almost all the sources I'm providing you right now are all on the internet. So most of the sources are Wikipedia based. So it's you can get most of the sources of the information I'm providing you there. But basically, with PVC, there's concerns about the plasticizers in the actual chemicals, and so they have these things like it's called butyl benzyl phthalate and DEHP, which is banned in Europe. So some of these are found in actual like toys and things like that. So it's definitely a concerning plastic. So I recommend doing a lot of research because it's a pretty complicated plastic and there's a lot of different forms of it. And some it's not just the plastic itself; it's what they use to soften the plastic with that actually is very bad. So, anyways, in general, I would avoid number 3 plastic. The other thing is if you microwave this plastic, 100% of the time studies have shown that it will leach chemicals. 100% of the time. So don't microwave this stuff. It's terrible for you. So the next plastic is called low density polyethylene, LDPE, and you can see it right here, number 4, LDPE. It's kind of a malleable plastic. You can see it in food containers. Sometimes you find it in just kind of malleable plastic bags. Some plastic grocery bags can have it. The other thing is food storage containers, things like that. It's a little bit less common, but it's considered fairly safe. And this is another plastic that I can say that I can't find hardly anything that suggests it leaches chemicals as of yet. I wouldn't take my word for it exactly. I mean, I recommend doing your own research, but so far it seems to be a fairly safe chemical from what I can see. So the next plastic is polypropylene. So it's bottle caps, storage containers, dishware. This is number 5 plastic right here. It's kind of a pretty thick plastic, but it's still kind of malleable. So this is probably what you'll see most food containers. So like yogurt containers, cream cheese containers. In fact, if you have this container, just look on the bottom there. It says PP, number 5. So yeah, this is the best kind of. This is a very common plastic. You do find quite a bit. So polypropylene is available in a lot of the grocery stores. This kind of plastic, in general, on the web, you'll hear a lot of people say it is safe. In my research, it looks like there are some controversies. For example, in 2008, researchers in Canada asserted quaternary ammonium biocides and oleamide were leaking out of certain labware of this. So it isn't perfectly safe, but they would consider it safer. But I still trust number 4 plastic and number 2 plastic more than I would trust number 5 plastic. Number 6 plastic is called polystyrene, which is basically a styrofoam, and I don't have any styrofoam to show you right now, but basically you know what styrofoam is. Styrofoam is actually kind of poisonous. Styrofoam contains carcinogenic styrene and estrogenic alkophenols, but estrogenic compounds are bad. As far as cancer-causing chemicals, obviously not good. So so if you're using styrofoam, certainly don't microwave it. Don't heat it up a lot. Don't do anything like that. I don't think you want to give yourself cancer. There's too much cancer right now, and it would be best if you didn't exaggerate that. Number 7 plastic is something that's a little bit harder to find. And number 7 plastic, like I said in the beginning, is a composite group all category for a lot of plastics that are not well defined. One of the examples is polycarbonate, which contains bisphenol A. This is the plastic that is the most controversial because bisphenol A has been something that basically dumbs down your body. It makes you your estrogenic qualities grow, so you don't grow like a man. You don't your growth is your sexual development is manipulated, and it messes with your brain. I've read some things about how it reduces your intelligence, but that isn't the only thing in number 7 plastic. There's technically some biologically created plastics that are biodegradable kinds of plastics in the number 7 category. There's ABS, SAN, acrylic, polyamide, and other kinds of plastics in that category. One thing that surprised me is I couldn't really find this plastic in a lot of areas, so I was thinking, well, maybe I'm not being exposed to BPA as much. Well, then I looked at my favorite orange juice, Simply Orange, as you might imagine, and I thought, oh, this is it looked like HDPE because it was a pretty thick plastic, or it looked like number 1 plastic. It was kind of shiny, so I assumed it was number 1 plastic, but no, it was actually number 7 plastic. So Simply Orange, the orange juice you find it's pretty popular in the grocery stores, is actually number 7 plastic, which is the kind of plastic that can contain bisphenol A, which is a poison. So I would avoid that. The other thing that contains BPA, when bisphenol A is very, very controversial poison, are things like this. Grocery receipts. These receipts have a chemical built into it. It's like a heat-resistant material, and that's what's BPA. It's actually in this chemical. And the thing about BPA is, once it's on your hands, you can't remove it. So even if you go to wash it off, it won't come off. So that's the controversy of BPA. So now that I've discussed the containers, let's talk a little bit about water. Okay. So water, H2O, is most people think that the main objective is just to have it pure. Purity of water is very important, but then you might ask, well, there should be minerals in there, right? Not necessarily. So what I used to drink quite a bit in order to avoid fluoride in water, because of the Harvard studies and other studies that have shown that the fluoride in water basically destroys your brain, is I started looking for glass containers, obviously, that didn't have all these chemicals that most plastics have. But I also looked for, natural water, and what you'll find is in the stores, you'll find a lot of spring water. And the spring water, you might say, well, it's a natural source, right? It must be good for you. But it turns out that natural sources of water actually contain a lot of things that are bad for you. They contain a lot of metals, which are toxic to the body. Most of these waters, including San Pellegrino, contain fluoride, actually, because fluoride is a naturally occurring mineral in a lot of rocks. And so dentists have shown that fluoride is good for your teeth in some cases, and it's a bare effect on reducing cavities. But ingesting fluoride builds up in the body, and it poisons the body, and it destroys your brain, which is basically one reason not to consume fluoride. So then you might ask, well, what is the best water to drink? How do you find pure water? It turns out that tap water is very, very bad for you because tap water contains, substantial amounts of fluoride and chlorine and other things built into it that are basically poisonous. In fact, in my water report, it was talking about radioactive materials in the water. So obviously this is not the best kind of water. So anyways, what is the water I drink? So I'm just going to go straight to what I do right now, and then you can evaluate what you want to do. So what I do is I drink distilled water. So the distillation process, if you're not aware of how it works, is basically you take water and you boil the water. So you raise the temperature of the water. And what happens is different elements have different boiling points, which means at a certain temperature, those elements will evaporate. And it just turns out that water has a lower boiling point in general than almost all things. Now, it's actually higher than some chemicals. So, for example, the boiling point of fluoride and chlorine is actually less than water. So what does that mean? If you were going to distill this yourself and get some container and capture the water and drain it into a container, and if you boiled it and you let all the steam come up into this container, you captured everything over there, yeah, you would get all your metals left. You know, all the solids and things like that wouldn't be in the water anymore. But your distillation process, because it isn't perfect, it would actually contain the toxic chemicals that actually evaporated before the water evaporated and got captured with the water. So that's why a staged distillation process is important. I looked up some information about how water is actually distilled, and it turns out that most distillation units have like a venting gas valve, so they have a way of basically allowing those chemicals to evaporate first and then capturing the water and then leaving whatever's left after it's been distilled. So I think most distillation processes should be following that. They probably have modern distillation equipment, and so it's reasonably safe to assume that some of the distillation units are probably capturing pretty darn pure water that's actually pure. So then you might ask, well, should I just drink pure distilled water? And the answer to that is actually kind of controversial. There's a lot of people who say, well, you don't have all the natural minerals in there. You know, I'm not as concerned about the natural minerals. You get a lot of minerals in all the food you eat, right? So you don't have to have that in your water. But are there some things that you can drink in water that affect you also? And there's something that turns out is actually very important to me, and that is the acidity of water. So I'm going to go ahead and show you how to test the acidity of water and also let you see the comparison of different kinds of water. So let me go ahead and grab a glass here. So this is tap water, okay? So you'd say, oh, well, tap water, you know, it's okay. Well, it turns out that the fluoride they put in there is hydrofluorosilicic acid. Basically, it's the fertilizer byproducts out of the chimneys that's got this fluoride gas, and they basically capture that gas, and they have these big hazmat trucks that they put all the hydrofluorosilicic acid in, and then they go to the water supply and they dump buckets of this hydrofluorosilicic acid, which is the waste byproduct of the fertilizer industry, into the water. In the early history, they used to use sodium fluoride, which is in a lot of toothpaste and mouthwash, which was a byproduct of the aluminum plant industry, and it was very convenient for them as well as the fertilizer industry to get rid of this waste and sell it to the cities because it's extremely expensive to dispose of. And we actually, because we fluoridate most of the water in the United States, while most countries do not, there are a lot of other countries that export their fluoride toxic waste to our country so we can dump it in our water supply. So China, for example, exports a lot of their fluoride waste to our country, and we dump it in our water supply. So anyways, so it wouldn't be surprising to you to find out that, can you guess whether this is acidic? So acidity is measured on a pH scale, which is basically the measurement of how much hydrogen ions are in the water. So it turns out that as you get closer to 0, that's the most acidic, and as you get closer to 12, that's the most alkaline. 7 is basically neutral, which means it's basically close to your body. It turns out your blood is actually a pH of 7.2, which is always kept at 7.2. So what happens if your body's pH goes below 7.2, or if you ingest a lot of acids, is your body pulls calcium and minerals from your bones to naturally neutralize the pH of your blood. So basically, if you constantly drink acids all the time, which means sugars, juices, tap water, distilled water even, it'll actually lower the pH of your body, and then your body has to compensate by leaching minerals out of your bones, which basically destroys your body. So raising the pH is actually an important thing. And as you can see here, there's actually a scale here. You can buy these test strips and basically you just dip it in the water and you can test the pH of different minerals. And so you can test your body too, and you can see, you know, the color changes. So as you can see, my body is a little acidic right now. It's probably around a 6.2 to 6.4 in terms of my saliva, but it kind of goes up a little bit. It sits on there. So obviously my body's a little bit acidic. So how do you maintain your acidity naturally? The best way to do that is consuming fruits when you want to lower the pH of your body if it's too alkaline, but if you want to increase the pH, to ingest more greens and vegetables and things like that, which surprisingly is what everyone tells you to do. It's actually true. It actually raises the pH of your body. So let's go ahead and test the pH of the tap water just to show you kind of what this looks like. So this is the pH of the tap water, and as you can see, it's kind of a lime green color, and it turns out if you put it on the pH scale, it's actually about 6.6 pH to 6.8. So it's actually slightly acidic. So this tap water in this area is actually a little more closer to neutral than the water I looked at before, which was actually a little more about, I think it was about 6.2 or 6.0. It's actually fairly acidic, but this tap water here is a little better for you than other kinds of tap water. So let's go ahead and test distilled water to show you an example of what this is. So you just drink pure water. What is the pH of it? And as you can see, the pH is really low with distilled water. So the lowest on the distilled scale is 5.5. This pH is about 5.5 to 5.8 pH. So this water, distilled water, is actually fairly acidic. It's even more acidic than tap water. It's very, very pure, but it's also very, very acidic. So how do you address that? A couple ways you can think of. I've heard that you can put some produce, like oranges and things like that, will actually absorb the ions. So theoretically you could put some slices of oranges or lemons or things like that in there, and I haven't tested that yet. You might give that a shot. What I do now is I actually put sodium bicarbonate in the water. So let me show you how I do that. So baking soda is a very common mineral that you can find everywhere, and sodium bicarbonate is, you can ingest it. It has sodium in there, and if your body, if you're too high on sodium, it's not recommended to put sodium bicarbonate in there, but it's a very cheap, very effective way to effectively raise the pH of water. So I've tried magnesium, different compounds of magnesium to raise it, and it's not very effective. It doesn't raise it that much, but sodium bicarbonate raises it a lot. So usually what I put in there is basically about a capful sodium bicarbonate. And you know how they say add minerals for taste? Sometimes the minerals they add for taste are really something as simple as sodium bicarbonate. This is the minerals they add for taste. So the other kind of mineral that can neutralize the water is called calcium carbonate. And sometimes you'll see that added for taste. Calcium carbonate, believe it or not, is what's found in chalk. And chalk and calcium carbonate tend to come from things like seashells, which of course, you know, if you're not by a coast, you probably don't have really good access to seashells. But let's go ahead and test the pH now that we put some sodium bicarbonate in there. See, now it's a lot more green, right? So if you look on the pH scale, it's about 7.0, right? So it's actually basically about neutral right now because of a cap full of baking soda. So that's what I do, and then I drink this water. That's my drinking water. So anyways, you can play around with different kinds of water. You can try. I'll show you some filtering water techniques here. On InfoWars, they have different kinds, and one is this clearly filtered one, which they have one that's sold out, or I don't know if it's sold out now, but it was. It basically kind of does the pH neutralization as well, but this is supposed to filter fluoride and other chemicals. I like this one because you can put it in the fridge and keeps it cool. You don't have to worry about bacterial growth or anything, and plus it's easy to grab, fill up, etc. Of course, you have the other ones that they promote on InfoWars and other places that you can look into too. But the important thing to realize is that most of the water filters do not filter chemicals. As you can imagine, a filter lets water pass through the filter and catches molecular content that's bigger than water molecules. So when you have ions, fluoride ions in the water that come from hydrofluorosilicic acid, then you're going to have the ions go through with the water as well, because the ions are actually smaller than the water molecules. So the filters aren't going to be effective for molecules that are smaller than water molecules, H2O. So keep that in mind when you're thinking about filtering, is that most of the filters out there on the market that you find in the grocery stores, like Brita and all those, they're ineffective. They don't actually filter chemicals. So you need a more advanced system to do that. They say, reverse osmosis can be effective. The thing about things like reverse osmosis and things like that, you're constantly replacing these filters, and the filters are very expensive. So and also you're leaving some things in the water, but you don't know what it's leaving and when it's good and when it's bad. So I like to construct water from scratch, purest water you can find, and put the stuff in there you trust, when you trust it. And if you want to have some special minerals and remineralize it in some way, you have full control over it. So please consider that as well. The other thing to do is keep in mind that storage of water is important. So if this is extremely high temperature, you might start to break down the plastic. You probably want to have a good supply of water. I have about 15 of these containers, 20 of these containers laying around all the time, and I'm always picking up a few more, and I'm always having a stock full of water as well as food, as well, which is more important than gold when things get bad. But having some technologies and understanding the processes is pretty important. So anyways, I hope you enjoyed this presentation. I hope you were able to learn some information from it. I would like to talk a little bit about other health matters in the future. So I'll probably next time I'll talk about the effects of something like mercury and other food products and some of the implications of that. Some of that information is readily available online. You can find a lot of it, but this is something I think is a little bit less known, so I wanted to focus on something very, very essential and very, very important first, and that is the purity of your water. So anyways, if you have any questions, feel free to contact me. Go to libertyfounders.org, or be able to go to our Facebook page, or like this Facebook video. Not this Facebook video, this YouTube video, and just be sure to stay healthy, stay safe, and get the word out. Thanks for watching. Bye.